Hi, my name is Dr. Ahmath. In this video lecture, we are going to discuss about the vectors. We will define them and we will discuss about the vector operations, both algebraically and geometrically. So first of all, let's discuss why we actually need the vectors. So one of the reasons why we need the vectors is to define some physical quantities which are coming with the two attributes. So essentially, with the magnitude and with the direction. For example, usually in physics, we denote the forces using the vectors because they come with the direction and also they come with the magnitude. For example, the most popular known force is the gravitational force, which puts all of us towards to the center of the Earth. And the magnitude of this force is similar, so is proportional to the mass of the people. So the higher the mass, higher the force, which attracts the objects into the center of the Earth. So another way of defining the forces would be, hey, so for example, you would like to run some sheep in the river, and the river is going to pull the ship to back, and you have to put some effort, some force in order to run this ship on the river. So in this regard, it would be really interesting to know for us that, hey, if this force of the river is equivalent to F1, the magnitude of this force is equivalent to F1, how much we have to put the efforts, how should be the magnitude of this force so that the ship is going to move on this river. So in this regard, we need to learn how to, for example, add the vectors or subtract the vectors geometrically. So let's discuss how we can do this. So before we do this, we're going to define the vectors first of all. So we are going to define the vectors on the rectangular coordinate system, and they're going to come with the 2 points, so essentially the starting point and the ending point. So essentially, for example, for this vector, the starting point is going to be given as the 2 and 3 point, and the ending point is going to be given as 11 and 8. So this is how we are going to define the vectors. So we usually define the vectors or denote the vectors using the small Latin letters U, V, or omega, and they are going to come with the starting point and the ending point. So one of the beauty of the vectors is that, or one of the features of the vectors is that you can put this vector to any location, any position, without changing its direction and the length or the magnitude. So essentially, we can change the position of these vectors without changing the look their direction and the magnitude. And now the thing would be like, hey, why don't we just always start the vectors from the origin? In that case, we would not need to store the coordinates of the starting point, right? So since all of the vectors are going to start from the origin. So in moving the vectors towards the origin is very easy. We just need to subtract the starting point from the ending point. So essentially, if your vector is given as using the starting point was the coordinates. So let me write it down. If your vector is given was the starting point was the coordinates 2 and 3, and ending point B was the coordinates 11 and 8, it is very much easy to move this vector towards the origin of the coordinate system. And the starting point here is going to be 0 and 0. And the ending point is going to be just the subtraction of the starting point of this point from the ending point. So in this case, it's going to be equal to the 9 and 5. Okay, so this is how we are going to move the vectors by subtracting the starting point from the ending point. So, and again, so now the idea would be we are going to define the vectors just using one point, ending point, because we assume that all of these vectors are going to start from the origin. So any vector which starts from the origin is going to be called as the position vector. Okay, so most of the time in this course of calculus or in any other course, usually we are going to work with the position vectors. So they start always from the origin, and we just need to give the coordinates of the ending point of the vector in order to describe the vector. Um, so the vectors are going to define with using so-called n-tuples. So the n-tuples are essentially the n numbers which are written inside the brackets, so that the order is important. So now the problem is we are defining the points with the n-tuples and the vectors with the n-tuples. So what do I mean by n-tuples? So essentially, we were working to so far with the two tuples, right? If you remember, we defined the point A with the two numbers, 2 and 3. It is called a two-tuple. Okay, so the two numbers which are written inside the brackets is called a two-tuple. The only thing is so the order is important. So if you change the order, it is going to be different two tuples. So essentially, 2 and 3 is not the same as the 3 and 2. It is going to be different two tuple. Okay, so we define the points with the n tuples and we define the vectors with the two tuples as well. And now, how to distinguish whether your given two tuple is the vector or the point? So here is the trick. So essentially, when we are going to define the point with the two tuple, we don't just we usually write down the two tuple just right immediately after the letter of the point. And when we denote the vector with the two tuple, for example, with the 9 and 5, we usually have this equality sign. So this is essentially the equality sign basically means that you are given a vector, not the point. So this is how we're going to distinguish between the vector and the point, which are given with the n tuples. So let me give you okay, so the n tuple is the sequence of n numbers which are written inside the brackets. And let me give you a small example of the two tuple and why the order is important. So let's say I would like to write a small script, small program where I would like to collect the height and weight of a patient, for example, in a hospital. So let's say I've got two patients and I'm going to store the height and weight in some array or in some two tuple. Okay, for example, for the first patient, I've got 165 centimeters and 60 kilograms. And for the second patient, I've got 185 centimeters and 90 kilograms. And you see, so I'm storing these numbers in this order, exactly in this order. So first this height is coming, then the weight is coming. And essentially, if I would just change the order of these numbers and write down 90 and 185, it would mean completely different things, right? It would mean that, hey, this patient, the third patient, is going to have 90 centimeters height and 185 kilograms, right? So it would mean this is going to be the height. So the first coordinate is always the height, right? And this is the weight. And this is much more different than for this patient, okay? So this is what I wanted to show you that, hey, two tuple is just the two numbers which are written inside the brackets with the comma, but the order is important. If you change the order, it's going to mean completely different thing. So now let's learn about how to do the operations with the vectors. So if you are given the vectors in R2, essentially your vectors are going to have like two dimensions as well, two coordinates only. So then if you would like to add them, you're going to just add the corresponding coordinates. So please note that if you are adding two vectors from R2, so from two-dimensional space, then your resulting vector should be also in R2. So if you add the two-dimensional vectors, you're not going to get a vector in the three-dimensional space or in one-dimensional space. You have to get a vector again in 2D. So the same as for the subtraction. So there is a typo, so there should be the minus. So if you would like to subtract them, you're going to subtract them component-wise. And the third operation is essentially if you multiply a vector to constant, again, you're going to get a vector in the same space, in the same dimensionality. You're just going to multiply a constant to all of the components of your vector. So essentially, this k is going to go inside the brackets and you're going to multiply all of the components of your vector to this constant k. So let's do a couple of examples on the addition and subtraction and the multiplication of the vectors as a constant. So let's say you are given two vectors. U was the coordinates, let's say 2 and 1, and V was the coordinates 5 and 3. So, well, if you would like to add these two vectors, you are going to add them component-wise. It's going to be 2 plus 5, 1 plus 3, and the answer, the result is going to be 7 and 4. Okay, very straightforward. So if you're given two other vectors, for example, if you would like to now subtract two other vectors, let's say omega is going to be given with the minus 7 and 3. And if you would like to subtract the omega from the v, what you're going to do is you're going to write down 5, 3, the v, minus 7 and 3. And you're going to do this component wise again. It's going to be 5 plus 7, 3 minus 3, and this is going to be equal to the 12 and 0. So this is how we are going to do the algebraic operations with the vectors. Nothing difficult, right? Everything is straightforward. So you just need to work with this. So now when you multiply a vector to the constant, it is very much straightforward again. So if you have some vector, let's say u was the coordinates 2 and 3, and if you multiply the k to be equal, so if you multiply this vector to 3, for example, then 3u is going to be equal to 2 times the 3 and 3 times the 3, which is going to be 6 and 9. Again, it is really important that if you have a vector with the two components, you are going to have again the vector with the two components. It is really important. Okay, so you have to keep the dimensionality the same when you add the two vectors or when you multiply a vector to the constant. So in this regard, it is really important for us now to define, to understand how to do the vector operations geometrically. So because do you remember in the beginning, I was interested to know how the two vectors are going to sum up geometrically, right? So I can give you a small example. So let's say you've got some object and you are moving this object to the right with some force, let's say, with a magnitude 2 newtons, for example, and you are moving this object to the up with another force, F2, let's say, with the magnitude 1 newton. If you're going to apply both of those forces at the same time, where exactly your object is going to move, right? So probably it's going to move in this direction, but I would like to know exactly in which direction, with which magnitude it's going to be applied. Okay, the resulting force, I mean. So in order to do this, we need to know how to add the two vectors geometrically. And it appears here is a way how we do this. So again, we've got these two vectors, u vector and the v vector. And if you remember, one of the features of the vectors was like, hey, I can move the vector to any place. We can change the position of the vectors without changing its direction and the magnitude, right? So let's just move the second vector to the ending point of the first vector. Then we can just connect the starting point of the first vector and the ending point of the second vector, and this is going to be the summation. Okay, so this is going to be the resulting vector. The same I can apply for this problem. So you've got this f, which is like twice longer, right? And I'm going to put to the end of the f1, f2. So this is f2, this is f1. And the summation is going to be this vector, so f1 plus f2. And the magnitude of this vector is going to be the length of this black vector. So this is how we add this. This is why we need this addition rule, for example, in order to understand the sum up of the forces, but there are more reasons why we need to know the geometric addition of the two vectors. So let's now discuss how we can subtract the vectors. And again, the addition was more or less clear. We just got one vector, we put the another one on the at the end of the first vector, and then we just connect them, right? Now the addition is that it appears we can subtract the vectors using the addition again. Okay, so if you need to subtract the u to the v from the u, you can write this down as the u plus minus v. So we are going to create a vector minus v. So and it's easy to create. You just need to get a vector with the same length but opposite direction. And now we are going to add the minus v vector, which is this vector, to the u vector. And if you remember, we do this by just replacing this vector to the ending point of the first vector, and we're just going to connect this. Okay, so this is going to be u plus minus v, or this is simply u minus v. But you see, so we did extra job by just multiply by creating this negative v, and we just put this to at the end of the u and so on. So I think it should be easier for us. So we need to figure out some easier way to subtract the vectors. And here is the way. So if you have two vectors, u and v, and if you would like to subtract one of them from the another, we are going to just put both of them to the same point, to start from the same point. Then we're going to just connect the ending points. Okay, and you see, so this black vector here is the same as this black vector, right? So both of these ways are valid to subtract the vectors. Okay, so now let me show you one more example again. So if you have the u vector, and if you would like to subtract the v from this, so if you would like to subtract another vector v from this, what you're going to do is you're going to just put both of these vectors starting from the same point, then you're going to add the ending points. So now the only problem is how to define the direction of this resulting vector. Because for the addition, it was more or less clear because you start from the starting point, you end with the ending point, right? So here, for example, you start this black vector from the starting point of the first vector and you finish this at the end of the second vector. While for this black vector, for this vector, it is not so clear because you're adding two ending points. And here is a rule. If you would like to subtract v from the u, so if you would like to subtract v from the u, the direction of the vector is going to go to the towards to the u. And the rule is the direction of this resulting vector is always goes from negative to positive, from negative vector to positive. So you see your vector v here is the negative one, right? And it goes, and the u1 is the positive. So that is why the direction of this black vector is going from negative to the positive. So this is how we subtract the vector. So this is one of the really important rules because later on we will see a couple of other theorems about the vectors, and all of them can be proven using the addition or subtraction of the vectors geometrically. So okay. Cool. And the last thing which I wanted to discuss with you is the multiplication of a vector to the constant, which is nothing else as a scaling. So let's say you've got this vector with the coordinates 4 and 2. Okay? If you would just multiply this vector to the 2, what you would get? You would get a vector with the coordinates 8 and 4. I just would like to try to understand what it does geometrically. Okay? If you multiply this vector here with the coordinates 4 and 2 to the 2, you are going to get this green vector with the same direction as the u, but which is simply twice longer than the u. Okay, so this v vector is going to have the coordinates 8 and 4, and it is going to have the same direction, but the length is going to be twice more. And again, it appears when you multiply a constant to the vector, it will simply scale the vector. It will just change the length. It doesn't change the direction of the vector. Okay, so for example, if you would like to get a third vector, which is going to be twice shorter than this red vector, just multiply the u to the 1 over 2, right? So this vector is going to have the coordinates 2 and 1, so this is going to be simply 1 over 2u, okay? And it is going to be, again, in the same direction as the u, but the length is going to be smaller. So this is what I wanted to discuss with you in this video lecture. So I hope that this was helpful for you. Thank you.